2.6 function notation. There's a lot going on in function in 2.6. So function notation, just to give it a name, to label it. Instead of y, everything is y. Why is everything y? Who knows? We are now writing f of x equals 5x minus 2. And as I wrote down here, does not necessarily have to be f of x, but f stands for function. We can label it g of x, h of x, k of x, a of x, whatever we like to do, we can do that. So, and f of x, that's how it is called in math language. And what else did I want to say? F of x is exactly the same as the y coordinate. Keep that in mind. Yes.
So is this 2.5 or 2.6?
2.6. So let's find f of negative 5. F of negative 5. F of negative 5 is, what we're doing is we're replacing the x with what now? Negative 5. My outer shell here is the 5 and the minus 2. That is what I call the outer shell of the function. Whatever is in the parentheses is the variable, and that changes depending on what I give you. So the answer here is what? Do the arithmetic. What? I couldn't hear you. Negative 12. No. And I know what you did. Don't say what it is. I know what you did because you did 5 and 5 is 10. Mm-hmm. Oh. Now, remember what I said about the first test? These are the mistakes you want to avoid, because I know exactly what you did. But we have 5 and nothing in between, in parentheses, that means multiplication. So 5 times a negative 5 is a negative, I already said the answer. Negative 25 minus 2, and we get here what? Negative 27. So if we were to list that as an ordered pair, I wonder what's going on with Ashley. I need to. That would be negative 5, negative 27. Are you coming to the Global Friends meeting?
I can.
Yeah. Okay. What is same function here? What is f of a? Y? That is y, yeah, but how do I write this out? F of a. Why did I pick a? Because I wanted a there. Hold on. F of a. Now my x became what? A. So what do I write? You replace the x with a. What do you have? 5a minus 2. Nothing else you can do to it. Easiest problem all semester.
I thought, because like, it was right by the f of x, I thought that it would be b because of the mx plus b.
Oh, no. We're moved on with the no, but I get what you're saying. Yeah, all I wanted you to do is replace the x with a, and that's all you had to do. You can't combine those two because those are unlike terms. Okay, somebody make up a function. f of x equals
-6 x cubed plus 12.
Okay, here you have it. A cube function. Okay, let's keep that in those numbers simple then. Let's find f of -1. Your turn. F of -1. Don't say it loud, at least not yet. F of -1. Last night I was doing something really cool. There's a global math department I belong to, and Tuesday evenings, like around 9ish, they have webinars and people giving presentations. And this person was given a presentation on Desmos, which was really cool, and we have to do that. See if it's free and I can just download it. He was doing square boxes, and we do that in chapter 3 when we do addition and substitution method. And it's like playing Sudoku almost, but you had to figure out if you have two variables, what the value. Well, it was really cool. I was sitting there like till 9:30 doing the puzzles. I'm like, I got other things to do. What am I doing? But that was really cool. So anyway, what is f of -1?
6.
18.6. Do I hear anything else? I know where the 6 is coming from. -1, -6 plus 12 and something cubed is our outer shell. That's the outer shell. Now, what we're changing, we're putting a -1 in here. Everybody good so far? Now we have to do the exponents first. -1 times -1 times -1. -1 to the third power is a -1, right? So -6 times -1 plus 12. -6 times -1 is a positive 6 plus 12 is 18. And our ordered pair is -1, 18. Okay, one last one. Same function here. What is f of a? Let's try this again. What is f of a? -6. A to the third plus 12. Done you are. Nothing to see, nothing to do here. Okay, let's pick a couple problems. Here I just wrote f of x is y, We're not doing these anymore because we've done them already. Function notation. Let's go to some in the book. I think they are in the book. Homework. So on page 159, you have f of x is 6x minus 2. G of x is -x squared minus 4x plus 1. H of x is 7. And k of x is the absolute value of x minus 2. That's exactly what you have in the book. I copied it out of the book.
Question.
Yes.
Okay, so during the test, right? And we do a function. Do we always have to put the ordered pair there?
No. I just put it there to keep it in the back of your mind that whatever value you're actually finding is your y value. Okay, so which one are we going to do first? 21 in the book says find g of 2. G of 2. Let's try this again. G of 2. G is negative x squared minus 4x plus 1. So now if you have more than 1x, you got to replace all your x's with 2. Let me write it down. The outer shell, something squared minus 4, something plus 1. That is my outer shell. And then the variables are going to be changed with 2. Now do the arithmetic. Equals? What? Negative 11? Negative 3? Negative 3 is you get from negative 2 squared is positive 4 minus 8 is a negative 4 plus 1 is a negative 3. I see where you got that from, but that would be incorrect in this case because the negative's on the outside. It's not negative 2 in parentheses. And see, excuse me, see how I wrote it? I put the 2 in parentheses. So this stays a negative 4 minus a plus 1 is a negative 11. Be careful about that. If the negative is on the outside, like so here, this really means, I think I have it, no, I don't have it. Negative x squared really means negative 1 times x squared. That's really what that means. Now, if you have negative 2 squared, which is a negative 4, if you have negative 2 in parentheses squared, that is a positive 4. Be careful about that. Okay, let's go back, find f of 0. F of 0, number 26, f of 0. Now you have to use the f function. Six times 0 minus 2 is what? Negative 2. How about 22? 22 is k of 2. K of 2. The k function is absolute value of x minus 2. What is k of 2?
Do we have to write the solution in order for like every time?
No. No.
Only when it asks?
Yes. Yeah. And I didn't do it here anymore. Yeah. No. Usually, I just wrote that down so you know what this means. What is k of 2? Do I hear something? 4 and 0 can only be 1. There can only be one Highlander, if you know that movie. There can only be one answer here. Brian is doing this here. Vince said 4 and 0. Which one you want to pick? One of the two. One is the correct answer. So the absolute value, you replace x with 2. 2 minus 2, when you treat that just like it was parentheses, 2 minus 2 is 0. The absolute value of 0 is 0. Yes. Okay. What was 41? I don't want to do 41, but I want to do 49. Ooh. What is h of 1/7? H of x is 7. H of 1/7? 1, I hear. 7, I hear. 1/7, I hear. Mine's well. Anything else? 48? No, nobody going 48. 1? How'd you get 1? I know how you got 1, but
If you multiply by the reciprocal, that is 1/7, they cancel out.
right. But Tori, remember what I said? The h of x or h of 1/7 does not mean multiplication. Now, the function itself for h of x is just 7. It doesn't have a variable. So there's nothing to plug in, right? So guess what? H of x equals 7. What kind of line is that? If we had to graph that, that is the same as y equals 7. Remember, all our letters of x mean y equals. So that's the same as y equals 7. And do we care what x is when y is equal to 7? No. So the answer here is 7. That is a horizontal line. Like I could be asking you what is h of a. That also would be 7. What is h of -5 here in the book? That's not 41, that's 32. H of -5 is 7. There is no variable to plug it in. That's a horizontal line. Keep that in mind. Okay, function notation. How about this one? What is this? This is in the book. On page 159, you have these individual points given, and then it's asking 54. Find P of 1. P of 1. What's P of 1?
Shouldn't say the answer.
No, okay, Caden.
I believe it's 0.
Caden believes it's 0. Tori is agreeing with you. P of 1. So that value represents what in your ordered pair? That 1, does it represent x or y? X. That always represents x. Whatever's in the parentheses represents x. So you have to go into your ordered pairs here, and you gotta look, where do you have 1 as an x value, which is right here. And so P of 1, the corresponding y value would be 0. That's why I keep writing those ordered pairs down. So hopefully you make the connection to this problem. If you have just ordered pairs, like for example, what is P of 1/2? 6. Yes. Yep. So again, there's no math to be done. You just have to know, and that's why I keep saying it, that whatever the P of or F of x values represents your y. Okay, next. Yeah, I wrote it again. Okay, what do we got here? 157, no. Oh yeah, next one. Still on 159. And then we have enough time for domain, and then we do 2.7 on Friday. Now, something else you have to be able to do, you have to be able to find the values from a graph. So these are functions here that are drawn. This is g of x and this is f of x. And that always, the way the language here is, the math language, is always difficult for students to understand. What is it that I need to look at? So if you, for 61, have to find f of 0, what does that mean? You have to find f of 0 in this graph. What answer would you give me? F of 0 is... So that means find y when x equals 0. That's really what that means, f of 0. So x is 0, 0 is right here, then you go up in your graph and find this point here, which is 3. That is correct. What is f of 3? F of 3, so now our x value is 3, and we go up until we actually hit the blue graph, and we go over and we read 1. Now, if this was an open dot, then f of 3, the answer would be D and E does not exist because it's not included. How about f of negative 2? Negative 2 is right here. So you have to go up until you hit the blue graph, and then you go over to see the y value is 1 as well. Guys, you with me? Look at the video again. Now let's take a look at D. For what values of x is f of x negative 3? So now you have to find the x values. Find the x value when y is negative 3. Where is y negative 3? Well, right here, right? This is y equals negative 3. What is the corresponding x value? If you go up and read the number, that is also negative 3. How about y equals 3? If y is equal to 3, well, it's there, but also it's at this point. So we have two x values here. X equals 0 and... What just happened? That's weird. Whatever I did, I could see what I had erased. I learned something. I don't know how to make this happen again, but... So 0 and 2. What is the domain? Domain are your x values. Negative infinity, because on the left-hand side that keeps going and your x values are negative over here. Somebody said yesterday in college algebra, I'm doing the same thing. Why is that not y value? But anyway. Where do we stop? At 3, and 3 is included, so therefore it's a bracket. What is the range? Negative infinity, because again it keeps going. You see the arrow there, that means it keeps going. And where does it stop? It stops, I see your point. The graph doesn't stop at 3. It just goes through the y-axis. The highest point of the graph here is 5. So 5. You got to go with the lowest and the highest. But you're not the only one who does that. So the lowest point, this arrow means it keeps going down, but don't stop here because the graph is crossing, that's your y-intercept, crossing the y-axis. You would only stop there if the graph wouldn't go any higher, but you can see that the graph is going higher all the way to 5. Okay? Be careful about that. Okay. Maybe we go back to 62 if we still have time, but I need to talk about something that is of the utmost importance. Domain. Domain. I wrote the domain down here already. Same thing we're doing in college algebra now, just a little bit more advanced. So the domain of a linear function is negative infinity to infinity. Because whichever value, if I plug in any value for x, I will get a y value, no matter what. There is no disruption of my y flow. I plug in a value for x, be it a gazillion or be it -2. I will always get a y value. And when that is the case, the domain is negative infinity to infinity. And the same for the next function, which in 2.7 we will actually graph them. That is a quadratic function. I could say f of x, it's a function, is equal to x squared, and is it defined for all x values? So in other words, whatever x value I plug in there, do I get a y value back? Yes. So therefore the domain of square function is also negative infinity to infinity. You want to try another one? Sure, why not? This already goes into 2.7 actually. So 2.7, we're talking 2.6 and 2.7 right now. The absolute value of x, we will graph it on Friday. Whatever x value do I plug in, do I get a y value? Yeah. Absolute value of negative gazillion is positive gazillion, so that would be a y value. The absolute value of a negative 100 is a positive, and vice versa. So yes, again, the domain of absolute value function is negative infinity to positive infinity. There's actually only 2 exceptions to the rule. Only 2. There are 2 functions where your domain is not negative infinity to infinity. So if you remember, the rest of them is always negative infinity to infinity. College algebra will be a breeze. But there are 2. Does anybody know or want to think about which 2 functions have issues? In other words, they are not defined for all x values. Any thoughts on that? Is there a function out there, or do you think what kind of function is not defined for all x values? Like all of these 3 here, whatever I do with x, I will get a y. Not a problem. 2 functions where that's not the case. Well, let's take a look at, before we take a look, let's take a look at 0 over 8. Why not? What is 0 over 8? 0. What is 8 over 0? Find. Now I can spell undefined. Oh, I have it right there. Okay. Don't need to write there. So, we do have some problems with some instances where we have a 0 in the denominator. And that would make anything undefined, meaning that's not a y value. So there's some issues with that. What's the square root of 16? The square root of 16 is 4. What's the square root of negative 16? You can't square root a negative 16 because that's a Narnia. Just like in the movies.
That's what it's actually called?
No, I made that up. I actually made that up. It's called not a real number in algebra. Narnia. Yeah, pretty good. Yeah. So anyway, the square root of a negative number is not a real number, and therefore we cannot graph it. So it's a Narnia. We cannot graph it. So obviously we have issues with functions that are square root functions, right? Because not all of them are real, and we can plug in number, we can't graph it. We also have issues, of course, fraction action. So we have issues when we have a fraction or when we have a 0 in the denominator. So let's take a look at this function here. F of x equals x plus 5 over x plus 3. That is called a rational function, but that's beside the point right now. The point is to find the domain. If I plug in any x value, will I get a y value? Always, always, always. So the domain should be negative infinity to infinity? You believe so? Caden believes so? Caden believes that the domain will be negative infinity to infinity for this rational function. Okay, so I already wrote it down. So ladies and gentlemen, students, go ahead and find me f of negative 3. We're going to see if, don't say anything anymore. We're going to see if Caden is correct for any value of x that I will plug into this function. I will get a y value. So what is f of negative 3? We just talked about function notation. That means, now what? That x is being replaced with what? Negative 3. Negative 3 plus 5 over negative 3 plus 3. Right? Negative 3 plus 5 is what? 2 over 0, and that's undefined. So that means this function is not defined. It didn't give me a y value. Undefined is not a y value. So it's not defined at negative 3. It's defined anywhere else. So if I were to say what is a domain, I would say all real numbers except negative 3. Why not? Because it's undefined. So for rational functions, you have to exclude the number that makes the denominator 0, undefined. I call this the restricted value, the RV. You have to exclude the RV. How do you find the RV? You set the denominator equal to 0 and solve for x. Did I say numerator equal to 0? No. So why do so many students set the numerator equal to 0? It happens all the time. Doesn't matter what's in the numerator. You set the denominator equal to 0. So in this case, the denominator is x plus 3. You set it equal to 0. You solve for x, and you get x equals negative 3. That is your restricted value. Now, in English language, math is a language, it would be all real numbers except x equals negative 3. Well, we're getting ready for college algebra or whatever other math class you take, and even if you take MGF 2106, you still may have to find a domain here and there, and that would mean you have to write it in interval notation. So interval notation, if I just show you on the number line, so -3 is bad, but everything to the left is good, and everything to the right, is good. -3 itself is a big no-no. If you look at that number line, the domain now is written as -infinity to -3, parentheses, that means -3 is not included, union -3 to +infinity. That is your domain. I'm sitting in the way. This is so important. It will be on test. It will be in college algebra. It will be in pre-calculus, will be in calculus, will be everywhere. Guys, you with me? A little? Now this function, if I were to graph it, and don't worry, you don't have to graph it. At -3, it is not defined. In college algebra, you will learn you draw an asymptote. 5/3 positive. So it looks somewhat like that. But that's beside the point. But there you have it. In general, the domain of a rational function is -infinity to whatever the RV is. Now in chapter 6, we may extend this a little bit and you have like a 3-part domain, but not in chapter 2. RV to infinity, that is kind of your rational domain recipe. You find the RV and then you plug it in there. Right? Right. Again, the RV is the value that gives you a 0 in the denominator. How about this little problem there? I guess it's 79 in the book. X minus 3 over x plus 6. How do we find the RV? You have no clue, I just told you. How do you find the RV? The first step is to set the denominator equal to 0, because whatever that is gives you an undefined. So what is the denominator here? Where's my little problem? I lost it. There it is. What's the denominator? X plus 6 is the denominator. You set it equal to 0. And then we solve, subtract 6, and you get x equals -6. That's the RV. So what goes in the placeholder? Fill in the blank. What goes in here? -6, -6. All real numbers except -6, because if you have a -6 here, you get a 0 in the denominator. What time is it? Oh, we're doing so good today, I could ask another 20 questions. What is f of 0? F of 0 is not 0. That is correct. So I'm asking you, what's the y-intercept? Find the y-intercept. That is f of 0. So what is f of 0? I know. What's the value of the y-intercept? goes, my green one is the function, right here. F of x equals x minus 3 over x plus 6. And I want you to find f of 0. Anthony,
Isn't it just negative 1/2?
isn't it just negative 1/2?
Yep.
How do you come up with that? Other than Anthony. Yeah, that too. It's time to go. The alarm's coming on. How did Anthony come up with a negative 1/2? Brian,
Because he took off the x's, these x's are 0.
isn't that what I asked you to do? So f of 0. I know it's a little small down here. This is our function. So the x is 0 minus 3 over 0 plus 6. What is 0 minus 3? What's 0 plus 6? How can you reduce that? 3 goes into 3 once and into 6 twice. That's how Anthony came up with negative 1/2. So your y-intercept is what? 0, negative 1/2. Oh, I'm going to be asking you on Friday all these questions. So it's coming again. These are questions on the test. Now, we didn't do the square root functions. We do them on Friday, and then we're going to graph a couple of these beautiful